Hello. Everyone hear me all the way on the sides? Are we awesome? Cool. So hi, my name is Matt Taylor. I'm one of the co-organizers of Boston AI. I'm the founder of Oments. Where's Matthias? Face blindness, there we go. Matthias is also a chief data scientist at Kayak. And then our other founder, Jeff Welpley, who's the CTO of GetHuman and Swish, is not able to make it tonight. Also, good news, it is not snowing, so we're here tonight as well. So, like, March is either February or April and nothing in between. I want to say a huge thank you to HubSpot for hosting it tonight. This is a awesome space, catered drinks and pizza. I also think it's kind of neat that HubSpot is one of our, I guess, real success stories in the Boston startup scene. IPO'd really successfully in, was it October 2014? They're up a measly 400% or something on the NYSE, $4 billion valuation. So I presume all of our startups will get there momentarily. So I'd like to bring up George from HubSpot, who's kind of playing host right now to tell us a little more.
Hello, everyone. Oh, you can't hear me.
They know the other mic works.
Hello? Yes. Oh, this one works. No. That's all right. So hello, welcome everyone. My name is George. I work at HubSpot, where we make sales and marketing software with a keen focus to help small businesses grow better. I'm a tech lead on our machine learning team, and we build our own platform and infrastructure for big data and modeling. If you're curious about what we do, feel free to reach out. There's a few of us here, but I'll hang out after the event. If you care about what we're building, what we're using, tech stack. So without further ado, I want to thank you for coming here. We have an amazing program for you, and hope you enjoy.
All right, so tonight we have a special treat. We have Andrew Therriault, who's the Chief Data Officer of the City of Boston. I had the good fortune of meeting Andrew through a machine intelligence gathering in Boston and run into him a couple other times. He's also spoken, I think, did you speak at the LIDS, Smart Cities? It's the Laboratory for Information and Decision Systems at MIT. I guess Andrew leads up Boston's citywide analytics team. You have a love for puns and corgis, so certainly ask him about that. Prior to joining the City of Boston, Andrew was the Director of Data Science at the Democratic National Committee, and you earned your bachelor's, master's, and PhD all at NYU. So that sounds like a fascinating decade in NoHo. And then received a prestigious fellowship at Vanderbilt Center of Study for Democratic Institutions. So please welcome Andrew Therriault, Chief Data Officer.
Is this mic on? Can everybody hear me? No? All right, let's give this a shot, and then if not, I'll use the hand mic. Well, thank you everybody for coming out, and I'm also glad it's not snowing tonight. This is the third time we've tried to make this happen, and so looks good so far. We managed to basically skip most of my first slide here, but just to repeat, I'm Andrew Therriault. I'm the Chief Data Officer for the City of Boston and run the city's analytics team. Did a poli-sci PhD and did about 5 years of consulting, mostly in the political and nonprofit space. Most recently, before this job, was running the data science team at the DNC up until the end of the primary in 2016. And today I'm going to just give you an introduction first to the city's analytics team, talk about some of the projects that we do, and move beyond what I normally give in this presentation, where I've done a lot of these where it's a very kind of rah-rah, look at all the cool stuff we do, cheerleading presentation. I do want to talk about some of the challenges we face in doing data science in the city of Boston. I've been there just about 2 years now, and I've certainly learned a lot along the way and really had some of my own expectations tempered by the things that I've discovered along the way. And so I want to share a bit about the challenges we've run into and also some of the things we've been doing to address them and what we're going to be doing to address those in the future. And speaking of corgis and puns, I was challenged about having a good pun in this presentation, which I don't, unfortunately. However, I do want to mention one project that is not in here. It's a project that I wanted to do since basically I started, which was to develop a machine learning algorithm to target people who are likely to adopt shelter animals, and I wanted to call it my pet project. So there you go. There's your bad pun for the night. We'll continue on now. So just to give an introduction to our team was created like a lot of things in government. Namely, it was created because somebody mentioned it in a speech. In this case, it was the mayor in his State of the City address 3 years ago. Before that, the team actually kind of existed. It wasn't so much that a brand new team was created from scratch. Rather, it was more that we had a bunch of people who did similar things, and they were basically given desks near each other and called a team. We had a lot of different programs that are still being run today. First and foremost around open data. That goes back to 2012. We've also been doing a lot of work in the area of performance management. Since Mayor Walsh came into office in 2014, we've been doing a lot of dashboarding, and I'll talk about that in a minute. We've also been building things like City Score, which is our sort of, marquee brand dashboard. Some of you might have seen it. It's really quite simple. It's a set of key performance metrics for the city as a whole that get aggregated up to give a very simple synopsis of how the city is doing at any given time. And then most recently on this timeline, last spring, just basically, I guess it was a year ago last Friday, we released Analyze Boston, which is our second generation open data portal. So some of the areas we work in, as I mentioned, performance management's a big one. A lot of the work we do stems out of tracking basic metrics about how all sorts of programs across the city are doing. Our team works closely with the mayor's office and the cabinet to track how each of the different departments is doing at achieving its core goals and living up to its service level agreements. We also do more in the area of data science, as you might know it as well, but that's something we've been moving towards over time, and that'll be a topic I get into a lot later on in this presentation. As I mentioned, we run the city's open data program. We also do what I call enterprise analytics, which is really about evangelizing data and spreading it throughout the entire organization. Just to give some context, our team's about 15 people. The City of Boston is an organization of about a bit over 17,000 with a budget of approaching $4 billion. So ultimately, there's no way that my team could ever do all the data work that the city needs. If it were 20 times the size, it still wouldn't be able to, and even if it could, that wouldn't be the right setup. One thing we've learned is really, really fundamentally important in an organization like ours, where all the 60-odd departments and agencies throughout the city all have very different areas of focus and specialization. It's as if we are the size of roughly a Fortune 500 company in terms of budget, but we do the work of 60 different companies on there in terms of the different things we focus on. And so one thing that's become really important is making sure that we have that subject matter expertise partnered with the data skills, which means not just doing all of the data work in our offices on the 7th floor of City Hall, but really building those skills out in the field so that the people who are coordinating ambulances or scheduling pothole repairs or whatever the case may be, they're able to access the data they need to do their jobs, and they're not just relying on us to do it all for them. So the kinds of things we work on really varied. As I mentioned, we work with almost every city department or an agency in one way or another. And so there's some really big problems that we can tackle. We work on things like public health and education and homelessness. We also do a lot of work in the areas of, for example, transportation, providing city services. As I mentioned, we do a lot to track how well we're performing and delivering all these kinds of services. But we also do targeted interventions. So, for example, one of our longest running projects in this area was figuring out how to deal with increasing ambulance response times. And this has been a multi-year thing. Since we started looking at these about 3 years ago, the first step is we saw that ambulance response times kept going up. We realized, well, the city's getting bigger in terms of people, traffic is getting heavier, the EMS system is staying the same size. So we realized, wait, we're just under-resourced. So that drove an investment in the FY17 budget to add on 20 new EMTs and 4 ambulances. We didn't stop there. We kept going and then started digging in more the next year and realized, well, part of the reason these response times are taking so long is that there are certain case types. And they're the ones that show up as unknown at the top level, and we dig in. And there are a lot of the kinds of cases that focus around things like addiction and mental illness and homelessness issues and so forth, and they were concentrated very geographically. So we worked with EMS to develop a new community action team model where we have paramedics with social work training traveling not in the full-scale ambulances, but in smaller vehicles or eventually on bicycles when the weather gets nice, so that we can deliver targeted care in these areas without distracting from the capacity to respond to things like heart attacks when they come up. So those are the kinds of things we often work on, getting at a very nitty-gritty level, but also trying to figure out, well, what are the best ways that we can really contribute in all of these different areas? And I'll talk about a few of those in a minute. So here are some of the things we've been doing in the 3 years since the team was created. As I mentioned, we do a lot of dashboarding. This is Mayor Walsh in his office. Those 4 screens, 3 of them are ours. On the upper right, you see the statistics for the Boston 3-on-1 program. 3-on-1 is our non-emergency service request system. We use it to triage literally about, I think, 130 different kinds of requests that come into the city. Basically, everything that doesn't require a police car or an ambulance or a fire truck can get routed through 3-on-1. And so we track the performance at answering all of those different case types, do those sorts of targeted interventions. We also get very meta with this, too. We work on things like 3-on-1 call response times as well. We're also down in the lower left, this is our rotating dashboard. That's the housing dashboard at that time. We also go through things like, for example, one of the more recent ones is the MBTA performance dashboard that we built to take and translate the statistics that the MBTA on its own puts out about its performance and makes it all really visible on one screen. But then we've also been doing things alongside taking those and bringing in, for example, scraped tweets when people talk about the MBTA to provide a little bit more context as to the differences perhaps between what is actually just reported in the statistics versus what the users themselves are actually saying. Very sort of straightforward thing, but it's something that really puts that kind of useful information in front of policymakers who might not be exposed to that firsthand on a day-to-day basis. And then finally in the bottom right, that is the city score dashboard I'd mentioned earlier. It's a very simple system where we simply look at performance over time, either if it's something where we're providing a service compared to our target levels of service, or if it's something which is a more general trend, we compare to historical averages. Basically what we do is we use it to figure out, is the city going in the right direction or the wrong direction? And it's a very simplistic reductionist thing. I don't think anybody would argue that this is a really ingenious way of doing statistics. The point here is to make it dead simple and visible and to provide the motivation for action when something's wrong. You don't need to think about, well, what does this number mean? If it's above 1, we're doing as well as we want or better. If it's below 1, something's wrong. And so when things are consistently below 1, that's when the mayor can call up a cabinet chief or a department head and say, what the hell's up with this? And then we can start to address it and dig down into the more detailed metrics that we have behind the scenes and start from there to figure out what can be improved. So we also do a lot of mapping. This is an example of an application that we piloted working with the fire department. It's called our Building Intelligence System. And it's simply a tool to solve a problem that was raised really by going on a visit to the fire dispatch center. And this is an example of what I mean when I say, you need to have this subject matter expertise paired with data skills. Because in this case, what happened was, somebody from our team went to fire alarm, the dispatch center, and saw they have a giant map on the wall with a bunch of push pins. And when they asked what those push pins were, well, those were locations of things like hazardous materials or active construction sites and things like that. Things that are really relevant for firefighters to know when they're going to a fire. We realized, well, you don't need a paper map with push pins. We can build that. And so we did. We built an application which, when you pull up a given address, it'll tell you about different kinds of building hazards and permits and so forth. And the idea here is simply to provide this information in a really easy-to-use fashion. It's a sort of dead simple tool, but the idea is to give that information before somebody gets on the scene rather than having them find out by surprise. This is also the kind of project that that I like because it shows how we can build things that scale well. In this case, scale well means, well, we might not use this exact application for some other purpose, but if you think about EMS or police or even inspectional services or other agencies, there are a lot of parts of the organization that are very interested in knowing when they go into a building what they're going to find when they get there. So it's the kind of tool in the future we want to build out so that we can have not only a desktop app like this in the pilot version, but also tablet and mobile responsive apps so that we can build this so that people who are going out throughout the city and doing their work can have all the information they need to do their jobs right at hand. This is Analyze Boston. This is our second generation open data portal. I give a lot of talks just about this topic, so I'll try not to get too distracted on it. But one of the things that we tried to do when building Analyze Boston was to think about, well, what is the weakness of a traditional open data portal? And the weakness there is accessibility. One of the mantras we kind of keep in mind is that just because information is available doesn't mean it's accessible. And what I mean by that is that it's all well and good if you build a data portal that people like us can use. Most of us in this room are some level of data experts. We're probably most or all comfortable downloading a data set, loading it into Python or R or even Excel or PowerPoint or Tableau. It's not PowerPoint, but you get what I mean. That's not the case for the majority of people, though. We're the oddballs. In the last time I gave this presentation, I gave a triangle showing the potential audiences for open data. And people like us are that little tip at the top. It's a very narrow audience. And what we realized is, the portal we had before, it was just a repository of data sets. It worked just fine for people like us, but it was missing out on the vast majority of potential users. So what we decided to do with Analyze Boston was to think about, well, how do we make this something that's useful for people who aren't just like us? And so we wanted to build a site which didn't just provide a list of data sets and a lot of download links. We're building functionality into it so that people can go and explore the data directly on the site. Or building, for example, and this is what I'm showing down at the bottom here, custom applications so that people don't have to be able to work with data directly to get value from it. Whether that's something like dashboards here talking about what we're doing on carbon emissions, or over here, a mapping tool for looking at the potential effects of climate change. We also have been partnering with the community. These two examples in the middle are actually, they came out of our Open Data Challenge last spring that we did around the launch of the site, where these were actually community-developed tools that we're sharing with all of the users here, because what we wanted to do is to provide different ways for people to get access to data beyond just going and downloading it and working with it on their own. We're also building other tools to communicate with the public. This is a series of dashboards around the city's Imagine Boston 2030 program. So Imagine Boston 2030 is Boston's first long-term plan in several decades. It's aimed at 2030, which is Boston's 400th birthday. And what it does, it outlines a series of goals in areas like, for example, housing and jobs and education and public health and so forth. And what we did is we built a series of dashboards. These are in Shiny, tracking how well we're doing now and have over time. And then the idea is in the future, as we get new results from year to year to year, we're able to put them on here and see how we're doing relative to the goals we've set for ourselves. And then getting into some of the stuff that I think you might find more interesting. We've also been doing a bit of work in the areas of machine learning and other areas of data science. Probably the most well-used predictive model that we have is our restaurant inspections model. So for the past, I guess almost 2 years now, we've been using random forest models to target our restaurant inspections. So in the city of Boston, we have a system where, depending on the category of food establishment, there's a mandatory inspection between 1 and 3 times a year. But then between those scheduled inspections, our inspectors can drop in wherever they think that there's a reason for doing an additional unscheduled inspection. And so traditionally, the way this has been done is that every inspector has their territory and they know the establishments there, and they basically just decide on their own where to go. And so what we did a few years back, first we actually had a hackathon that generated some ideas and prototypes, but then we took this in-house, and we built out a model that said, well, for every food establishment in the city, if we're going to go in and do an inspection now, how likely is it that we'd find a critical violation? And then we piloted this. We tested the inspector's own normal practice of using their intuition and prior knowledge versus lists of recommended targets based on the models we built. And we found that year over year and across the random sets of inspectors choosing on their own versus the models, we had about 20 to 25% higher rate of finding those critical violations when we do go into a restaurant. So we've been using this pretty successfully for almost 2 years now. Every week we send out a list of high-risk establishments for each inspector for their territory. And we found that it's been pretty effective in practice. It's actually an interesting model. It's what for the civic data space is often what I think of as like the entry-level machine learning model. Pretty much every city that gets into data science either starts with this or does this as one of their first ones. In part, it's because it's something everybody does, and it's not quite as sensitive as some of the other things you might do. For example, another one that comes up is things like fire risk. There's a lot more liability involved in that, but also a lot more complexity. And the positive rate for a restaurant inspection or restaurant code violation, obviously a lot higher than any given building catching on fire. So it's a little easier of a model to make. But it's an interesting one because we bring in a lot of different data sets. So yep. Yeah. Oh, sorry. It's a particular kind of machine learning model. A random forest? Yeah. Yeah. I mean, we tried a few different algorithms. That was the one that, and I think shouldn't come as a surprise to people who've worked in this area. Tends to perform pretty well and be pretty robust. But yeah, we use a lot of different kinds of features in here. As you might expect, a restaurant's own history is generally the strongest predictor of how it's going to do in the future. I'd be worried if it weren't, really. But then other things that we bring in, we have things around like complaints that are made to 311 or building code violations. But we also do things like pull data from Yelp. That was something that took, I guess, better part of my first year to arrange, dealing with all the legal aspects of that before we ended up basically kicking out the lawyers and just getting our engineers to talk to each other and find a way that they could share things that weren't actually secret. Basically, we had them do our feature engineering for us. But so now, not only do we bring in things like the ratings and cuisines and so forth, we also do things like flag how often they'll have something like reference to food poisoning or pests in a review, with the idea being that in a perfect world, and I say perfect world for people trying to do easy work at City Hall, every time somebody has a problem, they just call 311. But that's not how the real world works. If somebody has a problem, they often will get online and leave a bad review. And so we want to take that into account too. So by pulling from those reviews, we're able to take that knowledge, and if people start saying about a given place that, oh, they were seeing pests, or they got sick after eating there, or it was really dirty, or whatever, that's going to bump somebody's score up, all else being equal. And this model isn't anything that would really surprise you in terms of how it works, and I think it's actually a good example of what I like to think of as data science being common sense at scale. The point here isn't that it's smarter than our inspectors. It's that we can't reasonably expect our inspectors to go and read every Yelp review for every restaurant every week. That would be silly. But computers are really good at that stuff. So that's where a lot of the value is coming from here. Another model that we're about to put into production, whenever we finally get around to finishing the 3-on-1 upgrade that's been in the works the past, well, basically since I started 2 years ago. It's a model we built for the new web interface for 3-on-1. So just to give some context, there are 2 current ways that through the web you can submit a case in Boston 3-on-1. The main website is a place where you go, and there's a list of several hundred different kinds of things you can report. Of those, maybe 130, 140, give or take, are actual 3-on-1 case types. There are a bunch of other things which are that have nothing to do with 3-on-1. They're just information. The problem with that site is that if you have a particular problem, the burden is on you to go and figure out which of those hundreds of links actually reflects what you're trying to report. The second site that exists is it's actually an offshoot of our mobile app. It just basically provides the top 20 most common case types and then a giant other category. And in that case, it's a lot easier for you to use. The problem is that there are a ton of things that wind up in that other category. And the problem there isn't just that somebody has to go in and read what you wrote as a description and then code it by hand. The problem is also that it means we don't get the opportunity to ask follow-up questions or questions that are relevant to that particular kind of request. So what we decided to do when we were building out this new interface is to say, well, let's take the burden off of the user and put it on ourselves. And so what's the simplest, and most common, I guess I shouldn't say simplest, but most common example of machine learning that you'll see, it's usually search algorithms. Probably most of us Google things several times a day as part of our normal day-to-day life. This is not exactly a search algorithm because it's very purpose-built. But what we did is we built a machine learning algorithm. It just takes the natural language text that somebody might say. For example, there's a pothole in front of my house, or somebody ran over a squirrel, or whatever the case may be. We basically say, give us one sentence or so, and then we take that in, and we run it through a model to predict what the case type that's going to arise from that statement will be out of the, I believe it's 123 types that exist in the new system. And we've set this up, basically we train it in scikit-learn, we take the pre-trained model, we deploy it on a serverless architecture on AWS Lambda, we hook it up to an API, so that basically what happens is that if you type something in the web form, that hits the API, and that spins up the machine learning model, runs your text through, generates the prediction, that kicks back through the API to the web app, and so within about 100, 150 milliseconds, you'll see a list of, say, 5 suggested case types that we think it might be. So the idea here is simply to take that burden off of the user, put it on the site, so that, one, it's a more user-friendly experience. People are more likely to come back. But also, two, that we're able to get them to the right form so that we don't have to have a human go in after the fact, correct things, make phone calls to ask follow-up questions, and so forth. Basically, it just makes the site all around much more functional and useful both for the city and the users themselves. Another example, and this is something that we're actually working on in partnership with a group called Data for Democracy. So the example you see right here in this map, this is something that we built. It's called our Vision Zero Safety Concerns Map. So this is a crowdsourced application that we have. We built a couple years ago, and basically what it is, it's a really simple application that lets members of the public go in, click a different spot on a street, and say, this is a place where people speed, or pedestrians jaywalk, or there isn't a bike lane and there should be, or whatever. And we, in the end, got close to, I think, about 10,000 of these responses. Now, I look at this and I think, well, this is both awesome and incredibly daunting, because the fact of the matter is, we're never going to solve all of these problems, right? Even if we had the resources and capacity to address 10,000 different problems on our streets all across the city, we're not going to get that all done at once. Maybe we could spend 10 years and do that. But still, we need to find some way to prioritize. And so this led to the idea, well, how do we prioritize across all these different issues? And also, there are other data sets like where actual crashes happen. That's a big one, obviously. And other things too. How do we prioritize? Well, let's look to see where these things actually translate most into serious crashes with injuries and fatalities, and then use that as a way to prioritize our interventions. So we're working on this project, which has gotten very sort of wide-ranging, and hopefully eventually we'll build out something that is scalable and can be applied to other cities as well. But the idea is simply to take all the different sources of information we have about traffic safety, and through predictive modeling, find a way to say, well, how do all these different inputs translate into different degrees of risk throughout the city, and then use that to prioritize our different interventions in this area. All right, so that's what we've done so far. Where are we going in the future? Well, at the start, I promised this wasn't going to be my normal cheerleading talk. And by that, it's not all doom and gloom, but we do have some real problems to face. And I think the first of these is going to be familiar for anybody, having messy and disorganized data. Unless you're the newest of startups and working on just one problem and you've generated all the data yourself, you probably also have messy and disorganized data. but yours is probably not as messy and disorganized as mine because, like I said, we have 60 or so different departments and agencies, enough that I can't remember the exact number myself after 2 years. And they're all providing data from all different systems, everything from really standardized enterprise applications all the way to, Barbara's Excel spreadsheet or Access database or what have you. We're trying to bring it in from all different places. When I arrived, we had, I think, 6 or 7 different SQL Server databases. We had a bunch of geospatial databases. We had an SAP HANA appliance. We had all these other different systems that data existed in. We had, I think, 5 or 6 different systems used for data pipelines. We recently, and I'll mention this, and I'll get more into this in a minute, put out a request for proposals for a new data warehouse solution. And we set the city's record for the number of questions that came in about that RFP. We had, I think, about 360. And my favorite one of these, it was just somebody asked, well, why do you have your data scattered across half a dozen different SQL Server databases? And what I wanted to just respond, and I had to stop myself from being too snarky in this, but what I wanted to say was just, I know, right? That was the problem we were trying to solve. And this is, that's why we were doing this RFP in the first place. I guess they didn't quite get that. But this is something that is a problem not just because, we have to remember which database anything lives on, but it makes it hard to enforce things like standards for, say, location or date time formats or anything you would need to basically be able to combine data together in an efficient manner. Also, speaking about infrastructure, the other parts of data science infrastructure weren't there. And that's just a function of what large organizations' IT departments are used to. They're used to things like Windows file shares and email and virtual machines. I realized early on in my time in the city that this was going to be an issue because we had, actually this was about the restaurant model. That was put into production by a data science fellow, a graduate student, who left our team. And when he left, we had to put a piece of paper taped to his computer that said, "Don't turn me off," because it was actually being deployed on his desktop computer. And so that was obviously a problem. I didn't realize that until he was basically doing the handoff. So obviously that was a problem that needed to be solved. And like any good data scientist, my first thought is, all right, let's spin up a Windows machine, or sorry, a Linux machine, in order to at least deploy this on something where we can like schedule it with cron and have something that is actually meant to be on 24 hours a day. Baby steps. So I go to our network team and I get them to spin me up a virtual machine. But it takes about 3 weeks. I ask for it. A week later or so, they come back and they say, well, what kind of Linux do you want? And I said, I don't care. If I've heard of it, I can work with it. And then a week later, they come back and they say, well, how about CentOS? I was like, fine, that's great. I can do that. And so then, a week after that, I got it. And then I logged in and I type ls and I hit enter and it breaks because they didn't know how to attach storage to it. And that's simply a function of what the environment is. Every VM, or for the past several years that they'd spun up, had been Windows, because that's what is the standard. And that's totally common in large organizations. I talk with a lot of my counterparts in other cities. I run the tech infrastructure working group for the group called the Civic Analytics Network, which is basically the professional network of city chief data officers. And we did a survey of the tools people use. And almost everybody across the country, every major city that has an analytics program is using either Microsoft SQL Server or Oracle for their databases. And that makes sense because this position, my position, I was the first one hired in it back in 2016. The first chief data officer for a US city, I think, was around 2011, 2012. The second was 2013. And then it wasn't until about 2015 that this suddenly became a thing every big city thought they needed. And when you start out something like this, what you do is you grab whatever's closest at hand. And a large organization like a city generally will have some commercial database product that they use for everything, for all the enterprise applications and so forth. And so it makes sense. Well, that's easier to get than to try to get some network administrator who's been doing the same job for the past 20 years, the same exact way every time, to, say, learn how to spin up Postgres or MySQL. It's much easier to just go with what's there. The problem with all that is that that's not really made for data science. we're not building out these enterprise-wide applications that can go through years-long deployment cycles, and we'll have teams of 20 supporting them. You or I might build an application that is really just an application that we built and want to deploy just by ourselves. And that's not a really good use case for the kind of IT model that a large organization uses. Never mind throwing things like open source tools. It changes the dynamic in a way that ultimately what I realized in the city is we kind of needed to fend for ourselves because we were building something new. There are also a lot of other competing priorities trying to do data science in a city. There's always competition for resources and time and so forth. But also even within the space of data and analytics, there's a lot of work to do. That there is so much work to be done in really basic shit, like in cleaning your data, in putting it on a dashboard or emailing a report to somebody. Honestly, if we just did that, we could change a ton. Where realistically, if I didn't have an invested interest in really pushing us forward, we could easily just do dashboards and reports for the next 10 years and make a ton of progress. Because I'm not joking when I say we're an organization that's almost 400 years old that still does a lot of stuff on paper. So making the case for machine learning is really tough. And in a lot of cases, we don't need it. There are a lot of opportunities to make really big impacts by doing really simple things by getting the basics right. And so, why would you do something that's a lot more complicated for a comparatively smaller marginal impact when there are all these low-hanging fruit just in doing some really basic data work? And then lastly, the area of staffing and sustainability. Recruiting data scientists is hard. Anybody who's done data science management knows that. But we're doing it in an environment where, quite frankly, we're a local government. We don't pay market rates, right? We have a residency requirement so that, if you live right here, that's a problem. If you are 200 yards, I think, that way, basically, if you're at the Museum of Science or further, you're fine. It seems arbitrary. There's political and historical reasons for it. There are a lot of people in the city who think that's actually a really good idea. But it's pretty objective to say that makes it much harder, particularly when you have a lot of the talent pool living in Cambridge and Somerville and Medford and so forth, and not wanting to move a mile or two away for the sake of a job which pays half of what the private sector would pay. So that's a challenge that I have on a regular basis. Yeah, sorry. And if you're willing to take that job, it might take 6 months before you can actually start. So just getting that out of the way now. Usually it's not that bad, but it can. So what that means, though, is that we also have to think about building things out in a way where we need to make sure that if I build something today and then it breaks a year from now, if I'm not there, there's somebody else who actually knows how to maintain it. And that's a constant problem, and some of it can be solved by things like writing good documentation and putting our code on GitHub and not just in somebody's docs folder. That's the easy stuff to solve. The harder thing is saying, well, how do we make sure that we have the right skill sets on staff and that we're going to have those same skill sets in the future, even if we change what we're doing over time? All right, so I gave you all the negative stuff. Now I'm going to talk a little bit about what we're actually doing about that. So the first thing I had mentioned was, in terms of having our data scattered all over the place. That's a perennial problem. It's never going to be perfectly solved. We have a ridiculous amount of data. We're not going to be able to clean it all, get it all nice and organized. But there is some hierarchy to it. We do have a lot of enterprise scale applications. Our 3-on-1 system probably being the biggest one, but then we also have 911 records. We have our permitting systems. We have our HR and financial systems. Those things are pretty standardized, and once we get them set up, they tend to work pretty well going forward. So those can be cleaned pretty well. The bigger thing is really building the place to put all this data and organize it and provide access. So I mentioned we just did this procurement. We spent, it was about a year-long process once the writing started, but really this has been something I've been doing since I started almost 2 years ago now, where I recognized that this was a need because I'd come from the DNC, which has a 24-node, at that time it was about 70 terabyte HP Vertica cluster. and it was one place to go for whatever data you need. And everybody and every team had their own schemas on there. And there was a team of 4 or 5 engineers constantly, working on building new pipelines and getting everything nice and clean. And it just kind of worked, and everything was there. And I didn't realize till I didn't have it how much more efficient your work can be as a data scientist when you don't have to go searching for data every time. You can just explore. So, we just procured a new system. It's built on top of Amazon Redshift, as well as S3, has built-in ETL tools. It's a platform that I'd seen actually several years before I even came to the city. And I thought, well, who the hell needs that? Why can't anybody just write SQL? And then I got to the city and realized, oh, wait, that's me. Because my team no longer is a ton of people who just write Python and SQL all day and could do it in their sleep. I have those people, but I actually have more people who can do a little bit of that, but really their benefit is going and having meetings with people and thinking about programs and the best way to apply data and analytics. And I want them to be able to actually go and upload a CSV file into a database without having to go to an engineer who's a contractor that we pay $150 an hour for just to get a file in a database. So another one, developing the production infrastructure. I told the story about getting the Linux VM set up. That eventually led to our team getting our own brand new shiny AWS account, which after about 6 months of working with the network team, we finally figured out how to connect to the City Hall network. So that was nice. But we've built out a shiny server. We've got Jupyter notebooks on there. We're also, as I mentioned, using things like Lambda on AWS and the API gateway and so forth. And these systems are going to work together so that our team will be able to basically have our own end-to-end data infrastructure for both the data storage and management, as well as the more advanced data science and analytics that we actually do with that data once we've got it. I also mentioned the competing priorities. Well, what we've realized, so I came in actually as somebody who, I ran a data science team before this. I did machine learning all day, every day. I would be up till 4 in the morning doing what I call model sitting, which is basically, when I needed to have the model done by like 10 in the morning and I couldn't afford for this thing to break 3/4 of the way through training, I would stay up and just watch it and binge watch bad TV just to make sure that if this thing crashes in the middle, I can really scale down my ambitions for the number of trees in my random forest or the number of hyperparameter tuning iterations I'm going to do and restart it, and so it'll run in 2 hours rather than 12 like I'd originally planned. So that's kind of where I came from. I've surprised myself in a way because I've let myself be talked into walking back the data science a bit. What I mean by that is that I had a lot of people on my team telling me, like, dude, you keep trying to put a model in everything. Stop it. We have to fix these really fundamental things first. And I really tried to push back, but at the end of the day, they were right, because what I realized is when I wanted to build a model, it was actually really hard because we didn't have the data in the right place. It wasn't clean, it wasn't organized, it wasn't easily joined together. So we've actually stepped back a bit from that and instead focused on how do we get that stuff right. And the things I talked about just before this are a big part of that, the data warehouse, the data science platform infrastructure. So we're going back in this direction again, but as we're thinking about it, we realized the other part of it is it's not just that we're not ready for, say, doing models or experiments or what have you. We need to bring our stakeholders along. And so what we're doing, I mentioned early on how much work we do in things like performance management, metric tracking. And that's not just because that's another part of our workload. We're sort of seeing this as a holistic thing, where that's an easy starting point. Everybody can understand, what percentage of pothole cases do you complete on time? What percentage of streetlight repairs happen within 48 hours? That's a really, really easy data thing. Say you can break that down to say, well, do we have differences across, say, different streetlight repair crews or districts or what have you? Now let's build a dashboard and let the department head who's overseeing that click around and see on the map, oh, well, here's where the problem is. Or here are the particular kinds of cases that are problematic. Well, the idea is this can build up to something more advanced. And the goal really in all this is rather than us coming in as the nerds in the room saying, hey, here's a case for machine learning, what we want is somebody to say, well, here's a problem we have. Is this the kind of thing you can solve? Because at that point, we have their buy-in. We don't have to sell anybody on anything. Conversely, I think the thing that really sold me on this was when I saw that one of our grad student fellows had done a project for the Public Health Commission where they built this really cool model to say, of the people that we run into in our EMS system who we're treating for something other than a drug overdose, can we predict which ones are likely to have a problem in the future? And again, it's a common sense at scale kind of model. It's not doing any magic. It's reading a lot of like EMT reports for things like mentions of track marks or syringes or what have you. Pretty basic stuff. But this was something that was like, it was really interesting because what he found was, yeah, we can actually predict who's likely to have an overdose in the future, so we could direct proactive treatment to them. And then we presented this to the Public Health Commission, and they said, great, we don't have the resources to respond to all the people who've already had overdoses and need treatment. So how are we going to direct resources away from those people who we know have problems to people we just think, based on your computer stuff, might have problems in the future? And that was a case where, yeah, the problem was the data science became before the real world buy-in. And that was a lesson. We realized that's not the right way to do it. If we can slowly warm them up, it's more of a, you can think of it as a boiling frogs problem, or what somebody from the city archives said to me a couple months ago, how do you eat an elephant? One bite at a time. So that's kind of where we're trying to go eventually, is to get into all the fancy data science stuff. But for now, sometimes, yeah, we do have to make a dashboard and a report and think of that as a stepping stone. So lastly, the big question is always, building talent and capacity. How do we maintain this? Actually, just had somebody give notice this morning who's one of our most talented engineers, so it's particularly stuck in me today. Well, we've had to be creative with this. And so one thing we're doing, building the hell out of the talent we already have. So for example, we've made it part of our standard onboarding process that people are going to learn Python and SQL when they come on board, no matter what their role is. Even if you're basically just going to be a general data analyst, you're never going to touch a machine learning model, or you're never going to build one. Maybe you'll touch one because somebody else will build one for you. But in any case, you shouldn't have to go to somebody else to look something up in a database or to do some basic Python, data munging. So we're putting that training into effect, whether it's through online training programs, things we do in our team meetings, sending people to boot camps, things like that. We also realized, and this was much to my chagrin as somebody who always loves to do stuff in-house, we do need to actually rely on vendors, because vendors can scale much better and distribute workload across a lot of people, so that if I need somebody who's really, really good at say, tuning machine learning models or whatever, or say Bayesian models, if we don't have anybody who does that, but we had a use case, well, we shouldn't try to keep every skill set in-house. We should realize, yeah, some things we're not going to use them all the time. Better to maybe rely on others for help to expand that kind of flexibility and know that we don't always have to have it on staff to have the ability to have it in the future. And then finally, and this is part of the point of giving talks like this, one problem we really want to try to solve is how do we collaborate with the community. This has been a thing that I've been kind of thinking about since I started, whether it's around open data, whether it's around a lot of people who email me and say, hey, I'm a say, junior at BU, and I'm really interested in data and want to get some real world experience, and what can I do to help? I want to be able to find a way to say yes to that person. In reality, any of you who've done management know that even when you're hiring somebody full-time, it's usually a couple months before they get to like neutral in terms of productivity. For the first couple months, even full-time, usually you invest more in a person than you get back. Well, that makes it really hard if somebody's only part-time or volunteer. In a lot of cases, somebody can be really eager and talented, but at the end of the day, it's more work to get them on board to work on one of our projects than to just do it ourselves. But this is a problem I want to find a way to solve. And I mentioned that crash prediction model with the group called Data for Democracy. One of the examples we're thinking of is how do we find the right groups to partner with, but also internally, how do we set up the right collaboration structures? Thinking about things like how do we find projects that focus only on open data so we don't have to worry about data sharing agreements? And how do we connect potential collaborators directly with the departments who need help rather than trying to play intermediary and just basically making ourselves an obstacle along the way? So it's a problem we're continuing to try to solve. I'm hopeful soon that the city will have actually a director of civic research. We're working through creating this position as a sort of bridge between our an organization called MONUM, the Mayor's Office of New Urban Mechanics, which is the city's innovation office, and our team to think about open data, think about piloting new programs and so forth, and really, finding a way to leverage the community that's here and capable and willing and wants to help out. So finally, to wrap up, I think it's always going to be a challenge to do data science in the local government context. I'm not going to gloss over it. I pointed out some of those challenges here. There were others. But I think we've been moving in the right direction, laying the foundation to overcome some of those. And I think ultimately, though, it's going to be a community effort. Working in local government, we're doing it for the community, but I think we can't do it alone. Within city government, we're 1/1000th of the staff. But basically, I think we are 1/40,000th of the number of people in Boston. And so there's no way that we can handle all of the data needs the city has. And so I think going forward, to really expand this, we're going to have to build better relationships with the community and find ways to leverage the talent that exists all around us in Boston. So with that, if you want to learn more about our team, just go to boston.gov/analytics. Analyze Boston is at data.boston.gov. On my team specifically, we have several openings. Only one is posted right now for the principal data scientist on our team, but we also have several others in the queue, everything from entry level to more senior. Best thing you can do, honestly, just shoot me an email if you're interested. I'll connect you with the right people in the department and make sure when we have more things open up in the future. So with that, thank you for listening. Hope you found it interesting and useful, and I'm happy to take any questions you have.
Questions? I come around with the mic.
Some of you were talking earlier about the modeling and some of the things that you guys have done in that space. Maybe wonder about dealing with bias and auditing models and understanding what they're doing.
Yep.
Do you guys have a way of thinking about that or
Yeah,
anything?
yeah, absolutely. And every time I show the restaurant inspection model, I know that that question's coming up. I've answered it basically every time I've discussed this in any public forum. And I think actually that's a good example of why we haven't done more around data science, which is specifically that I'm very well aware of the potential problems of biases in this area. We've stayed far away from things like, for example, predictive policing. I don't want anything to do with that. We're not taking in, say, video feeds. I don't want the responsibility of all that personal information. As far as restaurant inspections go, it was actually an interview question when I was applying for the job a couple years ago. Exactly how I would think about the bias here. And so, on the one hand, there's a lot to worry about in terms of worrying about if you're a restaurant owner, that your restaurant is going to get profiled for, say, what type of cuisine it is or what neighborhood it's in. On the flip side, you can also think about it from the perspective of, well, why do we do inspections? Well, we don't do it to be assholes. We don't make a lot of money off of it. We do it to protect the safety of the people who eat at those establishments. And if I were to say, well, okay, I have this information that can make my model better at predicting where there's a high risk, but you know what? I'm going to ignore this information because I'm worried that there's going to be a disparity there. Well, I think the way I think about it is, well, if you're observing by the best information you have that the diners at that restaurant might be at a greater risk than everybody else, and you decide to ignore that, then you're putting them at greater risk than you would if you followed the model. Which is not to say one of those two ways of looking at it from the perspective of, is this punishing the restaurant owners versus protecting the diners? I don't think it's exactly one or the other. I think both are at play. I don't think there's a easy answer for the bias question, but I think the real issue is, well, how do you make sure that if there are biases in the model, that they're mitigated as best as possible? And there are two things that we do around that. One, this is a human-in-the-loop model. We're not punishing any restaurant owner based on just the predictions. When we make a prediction that a restaurant has a high risk score, what will happen is an inspector will go in there and poke around for an hour or so, and if there are actual problems, they will get a violation. And if there are no problems, they won't. So say we're wrong, and we've predicted a high risk when there's no high risk. Well, then in that case, we've basically inconvenienced an owner with having an inspector poke around for an hour. And the way the model's set up, once you've had an inspection, you're taken out of the potential pool for 90 days. So at most, worst case scenario, 4 times a year, somebody is inconvenienced by having a stranger in their place for an hour. I can live with that. It might not be perfect, and I'm not saying there's absolutely no downside to that, but that's an acceptable cost of being wrong in a model. But compared to things like predictive policing, where you might create some potentially violent confrontation, obviously that's a problem. Or just disparate, punishment or something like that. I think those are orders of magnitude more critical in terms of potential biases than something like this, where we do build in these safeguards. I think the other important part is that the way the model is set up, the most important features are the restaurant's own history. So it's self-correcting. If we're wrong in the prediction and we go in and we find, oh, this place is actually perfectly spotless, we're not going to go in 90 days later, even when that establishment gets into the pool, because they had a perfect inspection the last time. They're going to be considered low risk for a while, most likely. The model corrects its own errors and learns over time. And so, again, not to say that potential biases couldn't have a downside, but I think we've done a lot of work to mitigate them. And, like I said, my concern really in this is making sure that we're using this information to do the work as best as possible, because at the end of the day, we're not trying to be dicks about it. We're trying to actually protect the customers. And I think it's in everybody's interest that, if our model does something wrong, that it corrects itself along the way so we can go where our inspectors would be better spending their time.
Hi, good evening, Andrew. I just wanted to say thank you. That was a great talk. You and your team are like mighty heroes, and you're doing like heroes work. Just into your point about it being hard to scale your team and the problems you have, is open sourcing your infrastructure something that your team has discussed as an opportunity to scale and get kind of hackers from all over the world? And I can see consortiums forming around that with all of your other fellow heroes around the country. And a second question is around just driving civic engagement through exposing this data science. Are you able to kind of supercharge change within city organizations, using these metrics, and like what are some success stories around that?
Define supercharge.
Like as in like, it takes 2 years to make a change. Now we have the numbers. It takes less than 2 years to make a change.
Just for the sake of time, I think I might punt on that second one. I give the example of EMS response times. We're working on that. I think there are a lot of small examples like that of areas we work in. That's the kind of thing we work on every day. I wouldn't say anything gets supercharged in City Hall. It's still City Hall. And so, there's a lot of personalities to deal with and processes and procedures and so forth. I think it really depends, though, on the part of the organization and how fast they want to move. Because we have some partners who are super responsive. They're really begging us for more data all the time. We have others who, they take some cajoling and elbowing to get them to listen. It goes both ways. I think in terms of your first question, though, open sourcing, I think there's a lot of potential there. One of the reasons we haven't open sourced more from our team is simply because, as in any under-resourced organization, we sort of often look at our code and think, this isn't quite done, this isn't quite ready for somebody else to see. And part of it is thinking about being a government, a public organization. My concern is that people will try to use it, not be able to. We don't have capacity to provide support. I don't want to put out something that's incomplete or messy, or it's a cop-out. I willingly admit that. Okay, yeah, let's talk about that, because I'm more than happy to have ideas. But when I was talking about new collaboration models, this was actually one of the things I was thinking about was the real, big reason we don't bring in outside help on a lot of that is actually that the code we're running is like hitting internal databases and using things that aren't public, data sources. So it's really hard to get collaboration going there. But actually thinking about how do you do projects with, say, open data sets, that's an area where I think there's a ton of potential to involve the community. And we do work a bit with other cities on this stuff. But again, yeah, tons of potential there, very underutilized. We'll talk later.
So I feel like aggregating all the data in the data warehouse was a big step for you guys. I'm wondering how problematic or any challenges that were associated with aggregating all that data on one sort of platform. And also interested in maybe who you selected to provide that service.
Yeah. So this is something that basically we just wrapped up the procurement like last week. So we haven't done it all yet. It will be a great win when we do it. We're using actually a vendor called Civis Analytics. Civis, C-I-V-I-S. Okay. They basically have a suite of tools, which is a sort of GUI on top of AWS. So combining things like Redshift with ETL tools and data science tools. Anyways, it provides a user experience that makes it more accessible to more than just our engineers, but actually our analysts as well. But yeah, I think in terms of how we put all the data together, in terms of problems we run into, I think there's the conceptual problems and then there's the technical problems. Conceptual problems, I think every time I hear about somebody putting a lot of data together, immediately I think security and privacy. And I think the biggest thing with this, we're in the midst of wrapping up something that goes along with this, which is the city's first analytics data governance policy, which is basically, we're working with Harvard Law School on this right now. The idea is I wanted to provide a formal policy document that I can give to partners across the city saying, you give us your data, here's what we're going to do with it. So it includes things like levels of classification for different sensitivities of data and changing how we handle it and share it based upon that. And that includes things like access controls. Everything from, at the low end, things that are open data sets or might as well be, not a big concern. We've sort of already vetted this as public record, and that's an important feature in the city is that every record in government in Massachusetts is public record unless it is exempt for a specific reason. So it kind of gives us this, this metric to measure against because I don't have to quite worry about security as much if all you had to do was ask for it and I would be compelled by law to give it to you. That said, there are certainly higher sensitivity data sets going around. One thing our team, though, draws the line at is we're actually not dealing on our end with things like protected health information, student records, social security numbers, things like that. That's a deliberate choice again. Because of exactly, I think, these concerns of what happens when you put all that information together. We certainly don't want to create a data warehouse, which could be like the one-stop shopping for hackers or ourselves. If somebody within City Hall wanted to do something nefarious, not that anybody in City Hall would ever do that, but if they did, I wouldn't want to quite make it that easy. But that said, we're not taking in that high sensitivity data until we can get the basics right. So sure, we might take in some internal financial stuff that's not public. But we're certainly not bringing in, say, somebody's immigration status or what have you like that. And then from a technical standpoint, there's just, I think, a lot of the same challenges everybody faces in terms of how do you standardize data sets across sources and how do you wrangle different data owners to put their data in the same place in the same way. Those are just a lot of technical challenges. We have, that's just part of the basic day-to-day work.
You talked a bit about bias, but what about people gaming the system? Yelp has had problem with people being paid to write fake reviews, and you're using it as an input into your system. Politicians may want stories to come out some way. So how do you deal with that?
Yeah, so that's actually one of the reasons why we've chosen not to make our restaurant inspections model public, because like Chicago's is open sourced. They have it based entirely on open data, but yeah, we specifically. Had that in mind that we don't want to quite give away everything in there because it is enforcement related. That said, it'd be really tough to game that system enough to be worth it because at the end of the day, the amount of work required to do all that manipulation, it's honestly a lot less than just cleaning up your shit if you're a restaurant. If you're willing to put a lot of work in to pass an inspection or not get a failure. You could just spend it doing that actual work. That's it too. Like I think things like Yelp reviews, I think there's a lot more financial incentive for the public-facing stuff than the things that face us. That said, also we kind of we're looking for negative signals in there. We do take into account the overall review averages, but for the most part, like, just getting people to add more positive reviews won't cancel out the one that says, yeah, I saw a rat. So, I'm not.
More generally, because politicians might want to also have an impact on what you're reporting, right? And the city of Boston, if the current mayor doesn't like what your platform is putting out as the state of the city, they might want to change it somehow, right? What is the?
I mean, it's not something that I've run into. We'll be frank. Like, there's always a communication aspect with anything that's public facing, but like the City Square dashboard I showed you before, for example, that was an idea that came out of the mayor's office. It was definitely their choice to show the thing, but they don't see the numbers before the public does. Every morning the same numbers that are on the public website are what's shown on the mayor's screen. There's no choice being made of whether or not to show a number on a given day. So, yes, it is government, there is politics involved, but, for the most part, the numbers are what they are, and we don't, we don't allow them to be influenced just for the sake of politics. Yeah. If you shout it, I'll repeat it.
I was very interested in the map data that you had. Is that publicly accessible data that was in that?
Which data?
It was the map. When the fire trucks go to a particular area, it shows
Oh,
the
so
hazardous
yes.
waste.
So the application itself isn't public-facing, but I think most of the data in there is actually on the open data portal, because it includes information about the buildings themselves, which would be generally all of that's in our property assessment data. Includes things like code enforcement violations, which is an open data set. I think complaints. There might be a couple things that aren't in there, but it's mostly things that are open data. Yeah, it's something I would love to do. I think we did it as a pilot, which is basically one of our team members who kind of had some front end development skills in addition to some of the back end data skills built that. We thought it was cool. Then she left, and getting back to that whole skills and sustainability question, we realized, okay, we're going to have to basically refactor this from the ground up, probably build it in something. Probably some toolkit like Mapbox that's less custom, more out of the box for something like this.
But if you could push all your data to Redshift, and then every city push their data to Redshift, that would be
there isn't a great venue for shared infrastructure between cities. I think that there are certainly companies that would love to become that venue. Though maybe not that many, because cities don't pay that much for things. But yeah, I think there's definitely an opportunity there. It's just a question of who hosts it. Because I'm sure all of us have budget offices who, if we said, yeah, can you pay for something that we're only going to use like 5% of, and we're just going to give it away for free to everybody else, that would never fly. But there's also no great legal way to say, can we just pay 1/20th? That is what vendors generally are for in the government space. Yeah.
Everybody likes their dashboards, but there's a proliferation of dashboards. I was wondering if you addressed that issue and how you organize.
Oh God, yes. Oh God, yes. Dashboard proliferation. Yeah, that's a thing that happens. Everybody wants a dashboard. In the city, the mayor got a dashboard, and then got several dashboards, and then suddenly everybody in the cabinet saw the mayor's dashboards and wanted a dashboard, and then suddenly every department head who worked for somebody in the cabinet also wanted their own dashboards, and now like every department head has a dashboard, and yeah, no, it's viral. And the fact is, dashboards they are useful. Like I said, a lot of the value that we can provide is really just providing access to simple data. Which is really grating for a data scientist, that something so simple can be so useful. And we're actually working through this problem because, like 5 years ago, somebody who is no longer around, because there's been a lot of turnover, Thought it was a good idea to try to go down the road of using the SAP Business Intelligence Suite and getting like a ton of departments involved in this, building out a ton of reports. And then they left and nobody else really took it over, and it's just kind of hung out there. And then every time like we try to turn this off, we realize, oh, there's like 50 other people depending on this because they have reports built out from 5 years ago that have never changed, but we don't have anybody who can support it. These are the kind of things we run into all the time. I think the solution that we're kind of looking towards is thinking, well, this gets to that whole self-serve aspect, where part of the problem with dashboards, I think, is that nobody likes building a dashboard for somebody else. I think people like building dashboards for themselves just fine. So the approach we're taking is thinking long-term, we're building a data warehouse for our own team right now, but this is meant to be a sort of stepping stone towards building one that we can share with other departments where, if we share these sort of core data sets with them and, provide a way for them to get at their data really easily, and we build tools, whether that's, something like Tableau or Power BI or Looker or what have you on top of that, where with some very basic training, somebody can go in and pull their own data. I think the end goal is that if I do everything right, our team will at some point never have to make a dashboard again, because the people who want the dashboards will be able to make their own damn dashboards and we can do all the fun stuff. That is the long-term goal.
All right, we'll take 2 last questions.
Me? Okay. Hi, I have a question about prioritization. Could you speak to the process, because you used that word quite a few times, and how much of the process in deciding what projects would likely yield the best ROI? Because that's something that we run into all the time.
Yeah, so this is something that we've been really thinking a lot about over the past, I would say about year and a half. When I came on board, we were at this kind of interesting tipping point because the team was almost a year and a half old at that point, and it had just passed that point where our demand exceeded capacity. Before that, the process was basically begging people to give us work. And then by the time I got there, it was like, okay, there's a little too much work, but we can handle it. And then it got to be a lot too much work, and then it got to be like, please make it all stop. And so we actually had to spend a good amount of time thinking, what is it? What should we be doing? And we put into place a formal process for project requests and selection. And one of the things we were thinking about when we were doing that is, well, what makes a useful project for us to work on? So some of the things I mentioned a minute ago, things that are scalable in terms of, can we either use something we've already built for somebody else for a new purpose, or conversely, can we build something that then will have these other applications, say for different departments? But then we also think about, like, is this a good fit for our own team's skill sets? Does it rely, or does it, does it align with the city's sort of long-term goals, and are there programs behind that that are going to ensure that it's sustainable? I think, in terms of productionizing things, a lot of it is a technical challenge, which, you get the right people and the right tools and some decent resources there, you can eventually solve. I think the bigger thing for us is really figuring out what is it that we should be doing as a team, because, the challenge for data people in an organization like this is always, you could do a million different things. Everything the city does, there are 4 times as many departments as there are people on my team. And so there's no way that, any one person on my team could do all the data work for one department, let alone 4. Totally unrealistic. So we need to be really, thoughtful about where it is that we think we can deliver the most value, and narrow down the set of projects we get involved with based on that.
Yeah, thanks. I enjoyed that talk mightily. Just one question to follow up about getting your other folks trained up on serving themselves. So you mentioned like the BI tools. You also mentioned you kind of bit the bullet on having anyone who joins your team learn Python SQL. Is that like a viable or efficient way of spreading that throughout your other departments if you identify the correct individuals? I also have a stupid question, which is you have the open data back to like 2012. Do you have any plans to like extend that back in time? Is that a useful thing to do?
Oh, yeah. So no, sorry. Our open data program goes back to 2012. The data on there goes back further.
Okay.
So actually just Friday, Friday at like 6 p.m. before I left, extended our property assessment data back. It previously had been 5 years. Now it's 15 years back. It goes back to 2004. So yeah, we definitely go further back in time. Generally, we go back to whenever any given system we're pulling data from first went electronic. Before that, obviously, it's a little harder to do. We're not retroactively doing it, but it's what we have the city archives for. But yeah, in terms of the leveling up skill sets, yeah, I think one thing we've realized is that, excuse me, for our team, it certainly is easier to teach somebody SQL than to maintain some application that basically tries to dumb down combining data sets and doing basic transformations just to save people from learning SQL. That was basically why we're moving away from the SAP suite, because it's an entire ecosystem built around saving people from having to ever look at code, even though they're doing the same level of complexity worth of things. They're just learning it in a very locked-in, vendor-provided environment. Whether that's going to work for other departments, I would like to think so, but honestly, I have no idea. I think realistically, we're not expecting everybody in every other department to learn all this. I don't expect a cabinet head or a cabinet chief or department head to learn this. But what I'm thinking is, the 2 or 3 data analysts in the fire department or transportation or wherever, if they can already do Tableau, that's the kind of thing they're already doing. It's not that big a jump to learn SQL, particularly if we're providing that training. And as I mentioned a minute ago, long-term goal is that we never have to make a dashboard again. But the flip side of that is it means we're on the hook. If we're going to get to that point, we're on the hook to provide the training and the tools and so forth and the support for everybody else who is making dashboards, so that when they go to do it for themselves, they actually know what they're doing. So that's always going to be part of our work, and hopefully, if we do it right, I've learned SQL and Python myself. I've taught a lot of other people. It's not that hard if you really put your mind to it and have a good teacher. So that's what I hope we can provide.
Are they clamoring to learn it, or is that something you have to evangelize to make them aware that they can learn it and that it would be empowering?
Well, I mean, there isn't the demand right now because there isn't the place for it. In terms of having the tools where, we don't have an enterprise data warehouse where somebody in, the fire department or wherever can go and pull all of this different data together. Our own data warehouse is going to be the start of that. We're looking at our own team and a few select highly skilled people in other departments as the initial audience. And then over time, we're going to grow that out to be something that is more valuable to others. And when the data is there and the tools are there for people to use it, and all they need to do is write a basic select statement in SQL in order to get access to all of these things, I think that provides a much easier incentive. And ultimately, I don't know. We won't know till we do it, but some people will learn, some people won't. The question is how many.
Thanks.
Awesome. Andrew, this was fantastic. Thank you all for the great questions. Andrew, thank you so much for the time and the insights. This was amazing. I also would like to thank George and Gabriella and HubSpot for hosting us, and this was an amazing space. And they've done a lot for the city of Boston. Gosh, how big is your team now? Like 2,800 people or something? I was looking at your IPO docs and it was like, we employ 700 people. Just a little startup in the city of Boston. But thanks so much for hosting us. Thank you all for coming out. We're still working on our next events coming up. So we'll hang out for a little bit, at least I will, if you have ideas or suggestions for things that you'd love to talk about going forward. We're eyeing some stuff around pitching VCs, doing lab nights where you bring your own data. But obviously, we want to hear from you about what else we can do to help our community and help this kind of Boston startup system and machine learning environment be more exothermic. So you have ideas, send them my way, send them Matthias's way, send them Jeff's way. We'll also be on the Slack channel, or hit us up on bostonai.org, and we'll figure it out. So thanks for all for coming out. I'll hang around for a little bit if you want to chat. And again, thanks to Andrew. This was amazing. Thank you.